I don't know if any of you are familiar with the Paul McCartney and Wings song. It's called Let 'Em In. Someone's knocking at the door. Somebody's ringing my bell. Open the door and let 'em in. Whenever I'm on Zoom and I hear the ding that that makes me think of that song. I don't know why. It's like the song is way older. But anyway. Although this says rates and dosages, and then it should just be like a page. I just skipped over like one page. We'll start with converting between systems. We'll do a couple of these practice before you work on the second part of the 13 homework, some of which we practiced things for last time. All right, one of the tallest female basketball players in the country right now is 6 feet 9 inches in height. How many centimeters tall is she? So before I can use my conversion, what do I need to do first?
6 feet 2 inches?
Yes, good. So my 6 feet, 1 foot is 12 inches. So that gives us, we are, but that's why we're going to do it in 2 steps.
Okay.
So that'll change that to being 72 inches plus the 9 inches. So total, she is 81 inches. Now, do we have something in our conversion between US and metric that would allow us to change that? So we have 1 inch is 2.54 centimeters. We know our 1 inch needs to be on the bottom because they have to cancel. And then my 2.54 centimeters on top. And if you're familiar with those units, you might just like already know, well, I would have to multiply. But knowing where the labels are will help us, even if it's units that we're not familiar with. So I'm going to just round this to the nearest whole centimeter and say she's about 206 centimeters. What I had to the 100th was 205.74. So you could give me 205.74, you could give me 205.7, or you could give me 206. 205 would be incorrect. If you round it to the nearest whole number, round it correctly. Don't just truncate it and knock the stuff off. Don't just ignore it. Okay, if we have a drink cooler, this makes me think of sports. You know, we have like for the kids and you give your little paper cups. And it holds 3 gallons. So like the Gatorade thing, you know, that maybe they pour on the coach's head. Muhammad, do you ever have any kids want to pour stuff on your head? No? Oh, darn. I'm going to try to go to I'm going to go to some soccer games and try to. And I'm going to try to encourage them that. Of course, they probably just all have water bottles. They'd all just be squirting you with. You know, water is one thing, but the Gatorade and how sticky. Ugh, yuck. But anyway. So 3 gallons. And we want to change this into liters. So when I look at my liters is metric, do I have anything that takes me directly from quarts to liters? Or from gallons to liters? No. Not from gallons, but from quarts, yes. Yeah, so we need to first change our gallons into quarts. So 1 gallon is 4 quarts. Good. And then now that we would be in quarts, then we can do our 1 quart is 0.9464 liters. And before I even do any math, I can check that the right things are canceling, and I am left with liters on the top, which is what I want. So 3 times 4 is 12, as Muhammad has said. And then when we do 12 times that, I came up with, yeah, like 11.36, or maybe we just say 11.4 liters. Personally, I rarely round something to the whole number. Particularly a liter, like it's a big difference if you ignore almost half a liter. That's a pretty big difference in liquid. If I ignore that little portion of a centimeter in her height, that's not as big a difference, I guess. Also, when I round it to the whole number, if it doesn't tell me that, I always feel like I'm kind of lying. I know I'm not lying, but I feel like I'm taking some liberties with the data if I just, because it makes it look like, oh, it just came out to be a nice whole number. So usually I'll leave at least a decimal place if it doesn't say. But if it doesn't say, then I would accept as long as you have rounded it appropriately. So here we have lots of steps, and you may, I remember having to memorize for a high school class, the speed of light, but it was not given in meters per second. So, so I don't have this memorized. May have been in feet per second or something, but we're going to change this to miles per hour. So we're going to need to make sure we start way at the left, because we're going to have some major conversions to do. So this is meters for 1 second. And then if we want to know how many miles per hour, so your choice, you can take care of the time or the length first. Which one do you want to do? We got to do both. All right, so how are we going to get from meter? What's your strategy to get from meters into miles?
Meters to yards,
You want to go meters to yards?
or
I mean,
kilometers.
So we could go meters to yards, but on your list, you don't have directly a yards to miles. So that's going to take an extra step. So maybe kilometers, because then that goes directly to miles, right? We should get, I mean, sometimes the rounding makes it slightly different if we do it a different way, but so 1 kilometer is 1,000 meters. So we're dividing by that 1,000, or that part we could just move the decimal 3 places. And then we need, that would put us in kilometers. So now we can do our kilometers to miles, which is going to be on top, kilometer or miles. 1 mile on top. And our 1.6093 kilometer on bottom. We know kilometer needs to be on bottom because we want kilometers to cancel, and they don't cancel unless one's top and one's bottom. So now those calculations would put us into miles. Notice I personally rarely write anything down along the way. I just kind of check to make sure my units are canceling, and then I just get the one answer at the end. So if you ask me like, how many miles is that? I don't know, because I didn't do that part separately. Now we need to take care of our time, because right now, if we finished, we would be in miles per seconds. So what's my next multiplier? I want to get rid of seconds. How many seconds? So 60 seconds, 1 minute. And then again, they don't have to be next to each other to cancel. So seconds is now gone. We are now in miles per minute, but we are supposed to be in miles per hour. So what's our next step? I want seconds in the bottom. I thought seconds were already gone.
Oh, so you, no, oh, yeah, they're gone. Okay. So 1 hour, 60 minutes.
So who's going on top? Who's going on bottom?
60 minutes on top.
60 minutes on top. Why?
So you can go away with 1 minute.
Exactly. So that it will cancel with this one. And since what we want is miles per hour, we want our hours to be left in a denominator, not in a top. We don't want mile hours. We want miles per hour. And then personally, you can just multiply everything across the top and then leave that in the calculator and divide by the 1,000 and then divide by the 1.6093. If you want, you can divide, multiply. As long as you leave it all in there, should still come out to the same thing. I think part of why I don't like to write down the answers in between is because if there's like a bunch of decimals, I don't want to write down all those decimals, so I just leave it in the calculator.
What you got, Chris?
It should be big.
Yeah. 6 billion? No?
Just
Billion.
just 6 billion.
No, 6,700,000,000. 6.71.
I got 6.706, and then let's just say it goes on for a little while.
6.7.
Yeah.
6.7. You think so? 6.7, that would mean that light travels only like less than 7 miles an hour.
No, it's a much bigger number.
You said 6 point though.
I said 6.706, and I said it goes on for a lot longer.
But when you put a point, that's where the decimal is.
670 million?
670 million.
634,964.
Anybody else?
I got 670,616,629.4.
That's because we went from meters to yards, yards to feet, feet to miles that big time.
Okay, so repeat that one again for me, Jess.
670,616,629.4.
Okay, so
Okay, I got a completely different number, so I fixed mine. I forgot a number.
Okay.
if you did the way I wrote down, okay, if you followed the steps that I did, this is what you should get. Jess, when you did it, did you use the yards? Is that what you did, Randy?
I did.
Yeah, I just forgot 1,000 meters.
Ah, okay. So,
Yeah,
so the difference in those two answers, the reason I boxed the one I did is because if you followed the steps as I wrote them, you should have the number on top. if you use different conversion factors, which also shows even those conversion factors with those decimal places, they're rounded somewhat. And when we're multiplying by such a ginormous, how's that for a nice math word? When we're multiplying by such a number with large magnitude, when we're multiplying by such large numbers, even small amounts of rounding, even though you didn't round along the way, but because the conversion factors are rounded. So if instead of going from meters to kilometers, we went from meters to yards, and then we went from yards to feet, and then feet to miles, that's where the difference comes in. Okay, so like if this was on a test, then I would have both ways, I would work it out every different way I could think of. It's the measurements, the conversions between systems that throw things off. The measurements within the same system give us the same answers. It's the ones, no matter the order, but it's the ones like when we're using the different conversions between metric and English measurements that things change. So we should all get the same answer on number 11 because it's just staying in the same system. Okay, so 15 pints every minute. How many gallons per hour is this? So we got to get pints into gallons and we've got to get minutes into hours. So if we look on our list, we don't know. So I'm gonna always try to assume that if you know something else that you can shortcut this, great. If not, from the things that are on your list, you would need to go 2 pints is 1 quart. And then 4 quarts on the bottom is 1 gallon, which also does mean that there are 8 pints in a gallon. That would get us into gallons. And then it was minutes on the bottom. We want to get rid of the minutes. So 60 minutes. We want to be per hour. So hour on the bottom. And then before I start doing my math, I'm just going to check that my labels that I want to get rid of, I get rid of. And that I'm left with gallons over hours. Did you come up with 112.5? Good. And we should all come up with the same thing there because there's no ambiguity. The conversions have not been rounded. And that didn't even have to be rounded, right? It was just 112.5. So I think most of us would just know we could do 400 divided by 60 here, but thinking of how this would work using our multiplier, 400 miles. If I have miles, then on top, then my 60 miles per hour, the 60 is going to be on the bottom, 1 hour on the top. So I can use that 60 per hour. I can flip it over if that's what gets rid of what I want to get rid of. Then my miles cancel, and sure enough, I am dividing, which gives me like 6.6 repeating, or 6 2/3. So if I wanted to be really exact, this is 6 hours and 40 minutes. Now, if you wanted to get an exact answer like that, and you get 6 point all that repeating, here's how you can use the calculator to help you with that. Take your 6 point all that repeating, subtract 6 because you know that's 6 hours. Then in your calculator, what you have is all of this, right? And then multiply that times 60. And there's your 40 minutes. Or you could change it all to minutes. I mean, I suppose you could say 6.7 hours, but if I asked you how long something takes, would you say 6.7 hours? No, you'd probably say 6 hours and some minutes, right? All right, so now you have a second part for section 13. You have the table at the front. At the first problem is a table, it is just one-sided. So the first problem, you're doing your Celsius and Fahrenheit. And by the way, what's significant about 98.6 is not just a random choice, that's your normal temperature, normal average temperature, body temperature. And then a few of these will take more conversions. And for instance, on number 7, because it goes from kilometers per hour to feet per second, you could get, we will get different answers depending on when we do our conversion because of the rounding in the conversions. All right, and then also if you have questions about any of the other assignments, I am happy to assist. But probably part 1 would be to just look on 13. Have any of you ever done any coding, like computer programming?
I did a little bit of coding back in, I think it was like 7th grade.
Looked at CX50. Are you familiar with that?
Mm-mm.
It's a free, like, a free online coding tool. Harvard University. It's well done. I started it, but being here,
You kind of have some other fish to fry.
but it's very interesting.
So I think I've told you guys I'm taking a couple classes through Ball State right now, online classes. One of them is a math, like an algebraic reasoning class. And the other one is computer introduction to programming. And so I'm writing Python programming in Python. So I really enjoy it. It's challenging. It's like challenging enough, but then it's like that moment when I can like, it does what I'm like, yes, you know, I got it. Because if you run the code and it doesn't run, and then you're like, oh, and then it's like, oh, I gotta go back. Oh,
So you're already doing that? You're far in it. You're doing the coding already. You start with just like few lessons, just like understanding how.
well, I
Yeah.
mean, I'm paying
Once in a
$1,400 for this class.
Oh, man.
So I better be working something.
Yeah, there are some boot camps on like 70,000.
Yeah, this is a graduate class at Ball State, so it's, but, my other class at least, I'll get paid, like, there's like a grant that will pay for the math class, and I'm hoping, since this is also STEM, that when I turn my grades in, they'll pay for this too, but if not,
You're trying to do like what, cybersecurity stuff?
I don't really wanna do cybersecurity, but I have considered, like, if I don't wanna be in the classroom for the rest of my working days. My husband is 5 years older, so he will likely retire first. And, like, if I could do programming, I'm still old school, I still refer to it as programming instead of coding, but then we could travel and I could do that
do it all
anywhere. I could do it anywhere, like,
I'm not so much like excited about the work from home, I'm more the like work from anywhere. But like,
No,
get
that's right,
travel and all
but
that flexibility.
you can work from, but you have to sit in a, like, in a chair and actually.
Yeah,
you know,
sit
you
there,
don't-
do
you
the
don't
coding.
really- Yeah, you sit in a chair, you can be.
I
And
mean, unless
From
you
what
write
I heard
code
from-
to write codes for you.
so from what I heard from friends that are doing it, they say that your programming, they give you like a program. And they give you a date, and you have to get it done by a certain date.
Yeah.
So you don't have that flexibility of just like,
Oh,
Right.
but you do have flexibility.
to
You
go anywhere you wanna go.
You can do it wherever you want.
You just
I-
gotta make sure you.
I could do it at night.
Yeah, you can do it, yeah, you
Gotta
gotta
make sure you got
I
it.
could
Yeah,
be,
yeah.
I could be outside in the daylight doing whatever I want, seeing all the
Yeah.
things in the world.
Yeah, you
And then
can.
at night, when my husband just wants to watch TV,
Yeah.
I could be,
Yeah.
I could be working there. And if I just got into it and I just like pound it out and maybe I
You
work
figure
till,
it out,
I
yeah,
think if I work
yeah.
sometimes till 3 in the morning, but
I
other
suppose
times not.
you're good at it, like keyboard as well.
No, I suppose sort of thing. But you know, like sometimes like you kind of get into this. Okay, I can do this. So I just found out what my next assignment would be, and it's like pretty. He went like from the last assignment to this one.
Jumped. Yep,
Whew,
yep.
It's
That's the
like,
thing with the Harvard class, I'm like,
When
I
they
spent
figure
like,
like, are you learning just Python or you learning multiple scripts?
in this class is strictly Python. But like, I had to write code that will, so this is what the code does so far. I'll have to bring my home computer so I can show you, but so far what it does is you can, it asks you your name and then you put in your name and it'll say like, how many classes do you want to enter? And you can enter like your course names. They'll ask you how many credits are it and how are they and what was your grade? And then it will figure the GPA and then it will return a list of all your, like a transcript. And it will tell you like, you've earned this many A's, this many B, it counts how many A's, B's, you know, which doesn't seem so impressive if there's only a list of 5, but.
still,
And then we had to take, the last thing we had to do was we had to be like, to input a file. Like you could already give me a file where you already have some classes stored in this file. And I have to be able to open the file, get the file information in, and then you add to it. And then all of them figure the GPA and the grade count and make the transcript from everything, and they output it to a file. And I have to be able to do that in 3 different file types. 2 of them I call out to really easy. The third one, like the file type is a little bit tricky. The next thing we have to do though, but he didn't care if we didn't have to make it do all the things, we just had to be able to, we didn't have to get user input into that one. But we had to be able to open and save. Those things I could do, no problem. But the next thing, the user gets to decide if they're having file input. And then which type of file. And then I still have to make, like, there's all these, and then if they want to add more classes. And then you also, like, I had to also add things into it already of like, if someone just enters lowercase, then it capitalizes.
this is
Like
something like that, web
standardized.
design, web design.
I mean, you could use it for web designing, but this is more like this was like a user interface and then it was just like run, so. But, so we just keep adding more features. So like for a while I had a feature on mine and then I took it off, I might put it back, but. If when they were entering, if they said they got an A, then I said, congratulations on your A in this class.
Interact.
And so like, we didn't have to ask for the name, but I asked for their name at the beginning, and so then I say like, so Carolyn, how many classes do you want to enter? And then after they say 3, and then when they say, and then like his example was just like, what's the first course name? What's the course name? What's the credit hours? What's the grade? But I have it come back that I say like, what is the course name? And then if you said algebra, then my next question doesn't just say how many credit hours, it says how many credit hours was algebra,
Yeah.
like where I
You
use that.
can save that. Is that what?
Yeah.
So it's not, you don't have to like.
Oh, yeah, oh, yeah.
I'll restart it every day.
Yeah, it's, you know, like, the guy who did the Harvard class, you should check it out, CX50, it's really good, the guy, like the professor, the Harvard professor, and he said, it's still to that day. He said, to this day, I still have problems with when I have to like, when you have to start a program, like the beginning, it's still challenging, but he said there is that pleasure of like figuring it out,
Yes, that's,
you know,
me,
like.
like literally, like sitting at my kitchen table doing this and it's just
Like-
like.
Yeah.
It's like, oh, yeah, I got it. Like, yeah.
We never did anything like that. We just programmed robots to race.
Oh, yeah, that's cool.
Yeah, I heard machine learning is basically
Okay. Okay.
is the hardest.
But I didn't. Okay. Okay, awesome, good. Awesome. You feel good about this one or you need some help? I think this is the one. You know, yeah, I think like, okay, the sucks is up here, now I have to be down here. Yeah. Good. 6, 5, 4, blast off. 3, 2, 1.
I hope I'll see you tomorrow, Jess.
Can we tell here?
Oh, bye. Thank you.
Bye.
Can you see for me if I'm missing more? Looks like I have more than missing.